Now I'm going to start to talk about the vector or force along a line. When we talk about the position vector, it shows that the position vector shows a vector that goes from point A to point B. Now, what about that we have the vector or force along a line and we want to define that force? That's what I'm gonna talk about it now. So vector along a line. So assume that we have our 3D x, y, z. That's x, y, and z. And consider that I have a rope connected to the wall. I have a rope connected to the wall, and then I'm gonna push that rope with the force F. Now I want to find that force F and find out what's the direction of that force F. It's going to be along a rope or cord. One thing to remember is that if you have a cord or if you have a rope, they cannot resist the lateral force. So anytime that we pull the cord or we pull the rope or chain and thing like that, the force is gonna be along that rope. It cannot have any other direction. So one more time, if we have a rope and we pull it, the force is always gonna be along the rope direction. So if we want to find that force, how we can find that force, how we can define the force in that cases, is the force in that case is always the vector of force is its magnitude times the unit vector. So it's the magnitude times the unit vector gives us the vector. And what's the unit vector here? Is the unit vector is gonna the unit, if I define that as a r, so the unit vector is r divided by its magnitude, and r is xb minus xa I plus yb minus ya j plus zb minus za k. So if we have a point A and point B, assume that we have point A here and point B, and that's the position vector, and its magnitude is going to be xb minus xa squared plus yb minus ya squared plus zb minus za squared. So when we want to find a vector or force along a line, we always do this backwards. So the first thing that we calculate, we find the position vector and its magnitude along that line, and then we find the unit vector for that line, and then from there we times the unit vector by the magnitude of the vector, and it gives us the vector that we are looking for our calculation. Now let's look at the example that how we can find the force along a line. So let's have our XYZ coordinate system, and on this one we have point A at this location, which is going to be 3 and 2, and then we have point B, it's going to be 4 and 2, And then we know that we have a force along the line AB. So if we have the line AB, then we know that there is a force that going along that line AB, F, and it's 100 Newton. Its magnitude is 100 Newton. So we want to find that vector F and its direction. So we have the vector and the direction. So the very first thing, as I said, one we are going to do, we start with finding the position vector. So it's a position vector AB. We want to find the position vector going from A to B. Before we can do that, sir, so we have to find the coordinate of A and B. So the coordinate of A is 3 and 0 and 2, and the coordinate of B is 3 and 4 and 0. So these are the coordinates of A and B. So A is going to be 3 in the xy direction, 0 in the y direction, and 2 in the z direction, same and similar for the B. So the position vector AB is B minus A, B minus A, B minus A. So it's going to be 3 minus 3I plus 4 minus 0, J plus 0 minus 2K. So 3 minus 3I, 4 minus 0, J, 0 minus 2K. So this is, and if I simplify that, I'm gonna keep that 0 here just so you know it is there, but you can just ignore it and don't write it. So it's gonna be 0I plus 4J minus 2K. And this is the magnet, this is the position vector, and its magnitude is 0 squared plus 4 squared plus 2 squared. This is going to be 4.472. So we have the R and U. So we have the position vector and its magnitude. And to find the next thing that we need before we can calculate, we need the unit vector. So the unit vector for AB is R AB divided by its magnitude, which is gonna be again, it's gonna be 0I plus 4 divided by 4.472 J minus 2 divided by, so 2 divided by 4.472 K. And the force is, when we want to find the force is its magnitude times the unit vector AB. So we want to do the calculation. The force itself, okay, we know that's the 100 Newton. So it's going to be 100 Newton times that times 0 I plus 4 over 4.4 sorry, so 100 times 100 times 4 over 4.472 J plus 100 times 4.472 K, and it's negative here. So minus that. So 0 and J and K component. And that we have here. Now, one thing, I'm gonna write the UAB again to find. So this is the force in the vector format. And then we want to find it, so it's the force because we know it's along the AB and find it. The second thing is that we want to find its direction, and whenever we want to find the direction, we will go right to the unit vector here. So I'm going to write it again down here. So the UAB is 0I plus 4 over 4.472J plus minus 2 over 4.472K. And then also we know that the UAB is cosine alpha I plus cosine beta J plus cosine gamma K. So if we look at that and compare these two together, we'll know that, okay, cosine alpha is 0, cosine beta is this number, and cosine gamma is this number, including the negative sign. So it's going to be this number. So I calculated for alpha and for beta and gamma is the same thing. So we know that the cosine alpha is 0, then alpha is cosine inverse of 0, which is 90 degrees. The same thing, cosine beta is 4 over 4.472, which is gives us then the beta is 26.56, and cosine gamma is negative 2 divided by 4.472, then gamma is 11657 degrees. So this is how we calculate the force vector and how we calculate the direction of that force. So alpha gives us the direction of force, the angle between that force and x-axis, beta gives us the angle between this vector and y-axis, and gamma gives us the angle between f vector and z-axis.